Hi everyone, in this video we're going to discuss what the real nature of fire is. Like basically what exactly is fire made up of? Is it some solid material, is it some liquid, is it some gas, or is it some plasma, the fourth state of matter? Like for example, if you think about ice, you can say it's water, it's solid ice, it's basically some solid water that's made up of hydrogen and oxygen. And if you think about atmosphere, like it's a gas made up of nitrogen oxygen particles. So can fire also be said to be formed out of some chemical elements in the periodic table? Or is it like it's none of them and there's a new theory for this altogether? So in this video, we're going to get the answer for this. So let's check that out. So first we know about the electromagnetic spectrum, that the light that we have consists of different wavelengths, all the way ranging from the smallest wavelength from gamma to the largest wavelength, which is radio. And we know energy decreases in this particular order. And somewhere in between them is the visible light also, the Vibgyo colors that we actually see, which humans can see, others we cannot see. So with this, let's first discuss how light is basically emitted off an object. So there are two phenomena underlying this. First is in the form of a radiation spectrum, and second is due to some electronic transition. So let us first see what radiation spectrum is. So any body which is at some finite temperature. Now that temperature doesn't have to be very high. It could be any temperature above 0 Kelvin. So things as cool as ice or even colder than that can actually radiate light. So for example, take an example of sun. So sun is a body with a very high temperature. So temperature basically means that the molecules inside them are having kinetic energy. So the molecules are vibrating. And as I said, it's not the case only for objects like sun, very hot objects, true for cold objects also. So when something is vibrating, and we know accelerated charges produce light. So these accelerating charges, something is vibrating, it's basically accelerating. So it's going to give out light, but it's not going to give out just red light or green light or yellow light or any particular wavelength. It's going to give actually all the wavelengths possible. So that is how we get this whole spectrum. So we are going to get all the wavelengths that are possible, as you can see in this graph also, from 0 to infinity. But yes, at different temperatures, as you can see, intensity of different lights will be different. So for example, you can see over here, if the object is having 4000 Kelvin temperature, then it will be having most intensity of this red light over here. But if you have an object which is at a high temperature, let's say 7000 Kelvin, then it's going to have highest intensity of blue light over here. So all objects will have different temperatures, and accordingly it will give out all lights, but some will have more intensity. For example, if you take the case of 3000 Kelvin temperature, you can say just some hot tea. So actually light is coming out of it. It's just that it is lying in the infrared region, the thing that the energy that we can actually not see, the light that we cannot see. But we do feel it because we feel hot when we are present near some object which is hot, because it's going out light which is just not visible to us. But on the other hand, if you move to an object which is closer to an object which is having higher temperature, for example 4000 Kelvin in this case, so in this case the highest intensity of light will be given by red. So that is why this object is red hot. And if the temperature is even higher, for example some of the stars present outside the solar system, so there you would see 7000 Kelvin temperature, that means it will be going to give out high energy light which is blue. So that is how we basically get the different colors of stars. So stars which are hottest will have the color of on the blue end of it, and the coldest one will have on the red end of the spectrum. So now let's see how light comes out because of the electronic transition. So you know, this is the structure of an atom, and these are the different shells, n equal to 1, 2, 3, 4 and so on. We know that when an excited electron jumps from higher energy state to lower energy state, so corresponding to the energy difference between the two shells, light comes out in the form of photon. So as you can see over here also, as electron jumps from higher energy to lower energy, the energy difference between them is coming out in form of light. So when the energy difference is higher, like example in this case it's dark blue, and when the difference is a little bit lesser, then little different kind of energy is coming out. So that is how light comes out from electronic transition, and on the basis of this principle work the sodium lamps and the mercury lamps. So we know sodium lamps are mostly yellow in color and mercury are blue. So the reason behind this is that the electronic transition in sodium lamps, the jump of electron from higher energy to lower energy, is not that great as it is in mercury. So that means that more energy light comes out in mercury lamps, which is basically on the blue end of it, and sodium is comparatively lesser, so that's yellow. So now coming to the main question, what exactly fire is? So first let me clarify it. Fire is neither solid, liquid, gas or plasma. It's not even matter. It's just energy coming out in the form of light. So for example, we take this image of a flame on a burner. Since maximum fuel is coming out from the bottom, that region is going to have the highest energy when actually it burns. So since it has the highest energy, that means when highest energy transitions take place at the bottom, that part of the flame is going to give out light also of highest energy, because highest energy transition takes place when those electrons de-excite and come back to the original state. So the highest energy part of the visible spectrum is basically the blue region of it, and the other part which is going to have lesser energy, that is going to give out light of lower energy, which is basically the red end of it. So that basically is fire. So I hope you like this video, and see you in the next one.